Hello everyone. My lessons today is solve the exercises you do at home, and because I want you to easier to follow my lessons, so I will name when I have some exercises, I will name my lesson is assignment. So when you go to my channel and you want to find the videos that solve the math problem or solve the exercises, you can find with term assignment. And now let's start. Our assignment now today is assignment 0.1. Slope and linear equation. Okay. At home, I require you to do 3 assessments, and now I solve these respectively. Questions number 1. Find the slope of these line. The first one is through to -6 and 5 -12, and question B through 3 6 and -2 6. Okay, I think this is very easy. You just apply the slope formula. So we have m equals delta y over delta x, or rise over run. So the answer is -12 minus -6 over 5 -2. -12 minus -6 minus -6 is +6. So the numerator is -6 and the denominator is 3. So the last answer is -2. Okay, question B. Through the point 3 6 and -2 6. So m equals 6 minus 6 over -2 minus 3, and the last answer is 0. I want to review you that. In the questions A, m equals -2, so m is the negative value. M is less than 0. So the line is downward to the right. And in question B, we have m equals 0. So the line is parallel to the x-axis. Yeah, it's very easy, and you can watch again my lesson 0.1 to review some situations that m is greater than 0 and m approach infinity. Okay, this is the exercise number 1. We go to the exercise number 2. Now I want to have some paper to clear my board. Is it a rainy day? I just use some paper, waste papers to clear my board. Okay, maybe I clear the exercise number 1. So struggling. So dirty. So I want to use some alcohol to make it more clearer. Okay. Exercise number 2. Find an equation. Find an equation for each line. Question A. Through 1, 2 with slope m equals -2. B. Through 2, 0 and 3, 1 in slope intercept 4. And question C. Through 1, 7 with undefined slope. Okay, maybe I solve the question D here now. D, vertical with x intercept at 4. Okay. In the questions A, the line is through the point 1, 2 with the slope m equals -2. So we just apply the slope in the slope form. Maybe the point slope form, point and slope to find the equations of each line. So we can write y minus y0 is 2 equal -2 times x minus x0. x0 is 1. Okay, is in the point slope form. So you can expand it two sides to find a general form or another form. So we expanding two sides of this equation. We have y minus 2 equals negative 2x. Negative 2 times negative 1. This is the distributive multiplication. So we have positive 1. So we plus 1 here. And we change negative 2 to the right side and have y equals negative 2x plus 3. Okay. This is very easy, not difficult. We move to the question B. Through the point 2, 0 and 3, 1 in slope-intercept form. So we have 2 points. We have 3 forms of linear equations. It is point slope form, slope-intercept form, and general form. So when you do your exercises, if you don't have maybe your general form, you must this is just expanding two sides of the point slope form or slope intercept form. So in the first and the second form, slope intercept form and point slope form, you must have the slope. So when you have a questions that does not conclude the slope in this questions, you must calculate or compute the slope before write the linear equation. So the first step in this lesson, in this exercise, we must calculate the slope with the formula delta y over delta x. So slope m equals delta y over delta x. It is y1 minus y2 over x1 minus x2, or y2 minus y1 over x2 minus x1 is respectively. Not important the first is y1 or y2, but you use the y1 first. Then in the denominator, you must do the x1 first. It is respectively. It is the coordinate x1, y1, and x2, y2. So we have the m is delta y over delta x, the subtractions of y's coordinate over the subtractions of x coordinate. So 1 minus 2, 1 minus 0 over 3 minus 2. It equals to 1. And now we have a slope, and you choose one of both points, only one point, and you write the linear equation. I want to emphasize that you choose the first point or the last point, it will have the same questions and have the same last question, last answer. So I will determine the slope intercept form here. I choose the first part, 2, 0. Y minus 0, y minus y0 equals slope 1 times x minus x0, here is 2. Expanding two sides of the linear equations, we have y equal x minus 2. This is the last answer. Or another way, we choose the second point, y minus 1 equals 1, 1 here is the slope, times x minus 3. So we expand into size, and we also have the last answer is y equals x minus 2. So again, I want to say that you choose the first or the last point, it have the same last answer here. It's not depend on your choosing. Okay, we move to the questions C, the third questions. Through the point 17 with undefined slope. Undefined slope. Undefined slope, or maybe we can say that m approach infinity. So when you see the term undefined slope in your questions, it means that you must write the equations of the line perpendicular to the x-axis, or the slope is approaching infinity. So the line is perpendicular to the x-axis. I want to sketch a rectangle coordinate system here to illustrate these questions. I think that's easy, not difficult, but maybe make you have some confusions. Here we have a coordinate system, and the line go through the point 17. Yeah, here 17 maybe here. Go through this point, and undefined slope. Undefined slope is mean that is in perpendicular to the x-axis or parallel to the y-axis. So our line here is this one. And the equations of this line is x equals the x coordinates of the point 1. Very easy, but maybe it's easier make you some confuses. Okay, and the question D, vertical with x-intercept at 4. It is the same questions. It is the similarity questions, the similar questions like question C. It is in the paraphrase the questions, and so we have the same answer here. Vertical with x-intercept. Yeah, vertical with x-intercept is perpendicular to the x-axis. So the answer is x equals 4. Okay, that is the fourth questions A, B, C, and D. Maybe I clear my board and we move to some more questions. Okay. equations like this, we have a rule around to show the set of all the linear equations. Question E. True -1, -3, and parallel to the graph of y equals 3x minus 5 in general form. Okay. Our line in question is parallel to the graph of y equals 2x -5. So I want to review you the formula when d1 is parallel to d2, and in the slope intercept form we have d1 y equals mx m1 x plus b1, and d2 y equals m2 x plus b2, and d1 is parallel to d2, so the formula is m1 equals m2 and b1 is equal to b2. So we apply this theorem to solve the question E. Yeah, we have m1 is 3 and b1 is -5. So the linear equations, the questions require us to write is y equals m1 equals m2, so this is 3x, and b1 is not equals to b2, so we plus b or c here, maybe b. And this line is through the point -1, -3, so we substitute the number for the letter here, so we have y is -3 equals 3 times x is a -1 plus b. So b equals, it is a -2, and we change the sign of this number. We have a -3 plus 3, so the last answer is b equals 0. And we rewrite the linear equations. Y equals 3x plus b, and b equals 0, so we plus 0. This also means that y equals 3x. Okay. This is the question E, and we move to the next fraction. Through the point, go F. Question F. Through the point 2, 3, and perpendicular to the graph of 2x minus 3y equals 7. So it is the first theorem about the parallel. And when we have the term perpendicular, I review you in the lesson 0.1. You can watch again my lessons. I uploaded this in the YouTube channel before, but in my assessment review, I want to review you the formula. Is very familiar with you when you do some your exercises in your school or maybe in your we have a perpendicular here. When you have a perpendicular to, it is very easy to remember. It is m1 times m2 equals -1. I want to some minutes to illustrate this formula by using the geometry. We have a coordinate, and we have a D1 and D2. Two lines are perpendicular to each other here. So M1 is the 10, the tangent of D1 here, θ1, and M1 equals tangent θ1. θ2 here, and the geometric meanings of slope is the tangent of the angle between the line and the x-axis, so M2 agree equals tan θ2. So M1 times M2 is M1 times M2 is tan θ1 times tan θ2. And θ1, θ2 here, we see that the sum of θ1 and both angles is equal to 180 degrees. So tan θ1 is have a value, negative value of tan θ2. So the answer is that's important θ2, and the last answer is negative. Maybe we review the identity when we learn the lessons 0.3. It is about the trigonometry section. Okay. Maybe you don't want to remember this theorem. You just remember that when D1 is perpendicular to D2, the formula is M1 plus M2 equals -1. So we have two methods to solve the questions F. The first one, I want to use the formula applied. M1 plus M2 equals -1. I clear my board. we see that when you applied the formula, the d1 and d2, you must write it in the slope intercept form. So the first step is rewrite or change the form of the line here, 2x minus 3y equals 7 to the slope intercept form. We have 2x minus 3y equals 7. So negative 3y equals, we change this to the right side and we change the opposite side of coefficient 2, so we have negative 2x plus 7. Divide both sides by negative 3. We have y equals 2 over 3x minus 7 over 3. Yeah, it is the slope intercept form of the line with equations 2x minus 3y equals 7. So m1 plus m2 equals negative 1. This is also m2 is the negative reciprocal of m1. So m2 equals negative 1 over m1. It is very easy for you to see that the m1 is 2 over 3. So the reciprocal of 2 over 3 is 3 over 4. You change the numerator and denominator. Denominator become the numerator, and the numerator is become to the denominator. So we have the line, and just remember that at the negative side for the D2 linear equations. So we have a negative 3 over 2. 2 over 3, and here is 3 over 2, and you add the negative side. X. And the same way in the questions E, you must plus B here, because you don't know what is the intercept with the x-axis. So you must plus B and you solve B in the next step. Our line is through the point 2, 3. So you substitute the coordinate of this point to the linear equation and you solve the value of B. We have y equals 3 is equal to negative 3 over 2. X here we substitute by the number 2 plus 2, sorry, times 2 plus B. So B equals 3 equals negative 3 plus B, so B is 6. And we rewrite the linear equations, substitute B with the values of the number 6. And we have a last answer. Y equals negative 3 over 2x plus 6. It is the slope intercept form of the line. And when we multiply both sides by 2 and we change all terms to the left side. We have a general form of this line. So if you want to expand it, expressions or equations or maybe something, you can rewrite it. 2y equals minus 3x plus 6. So the last answer is 3x plus 2y minus 6 equals 7. If our questions don't require the form of the linear equations, your answers maybe can write in the slope-intercept form here, or the general form here. Both of them are correct answer. And when the questions require exactly the form of the linear equation, you must write correct form the questions required. This is the slope-intercept form, and here is the general form. And as I teach you in the lesson 0.1, we have another method to do the questions F. Is it easier for you when you don't want to change the general form to the slope-intercept form for the first line? So maybe when you compute it's really easy to solve the question out. Maybe in your answer, the detailed answer, you can write it after write the form of the line question require you to solve. And two theorem here. And we have option 2. It is option 1. And now we have option 2 to solve questions F. The questions have a line 2x minus 3y equals 7. So when you see the term perpendicular to here, you just exchange the coefficients before x and y and change the sign of one of two coefficients. Only one. 3 here, negative 3. You must take the sign before the coefficient, so we have negative 3. Negative 3 is in positive 3. 2 here is also 2. You change the sign only one of both coefficients. X plus 2y equal B or C is in the ladder represent to the variable, so you can choose B or C. Is it not important? Maybe we can write C, or maybe we can write B. But I see that people usually use C here, use that C to represent the variable, and the F go through the point 2, 3. Okay, so we substitute the coordinates of this point to x and for x and y, and we have the last answer. 3 times x is 2 plus 2 times y is 3 equals c. And so the answer is c equals 12. So the last answer is 3x plus 2y equals 12, and we change the number 12 to the left side, and we have a general form 3x plus 2y minus 12 equals 0. It is the same. Oh no, maybe it is wrong. Oh, okay, I see my mistake here. I forgot to multiply 12. Multiply 2 here, so 6 times 2 equals 12. I'm so sorry for my mistake. And the last answer is also the same. Okay. So after this questions 2, we have a review some method to solve the linear equations in the slope-intercept form, general form, or point-slope form. So I think that it is now easier for you to do the exercises in your school or on your upcoming exam. We have a more difficult question in the last lesson the day before. Is it about the collinear? And I want to claim about to show these questions. Okay. I write my question. Show work to determine if 2, 5, 7, 0 and negative 1, 11 are collinear. polynomial is mean that their 3 points are lying on the same line. Okay. As I say in, as I said in last sessions, when we define a line, we must have 2 points, A and B. And this is a very special situation that 3 points lies on the same line. 3 point line on the same line. So see here, or maybe see here. It is 3 point line on the same line. We use a term called linear. So to show work to determine this question, we have a lot of ways to do, and maybe now I will show you two ways to do this exercise. Yeah, option 1. You choose 2 points of 3 points, and you write the linear equations through 2 points. And if the last one lies on the same line, so the coordinates of the last point, when you substitute the value, the coordinate to the linear equations, you just write before. It is have the equality. It has the equality. So we do here. So the first step 1, write the linear equation of the line. Goes through 2 points, 3, 5, and 7, 0. It is very easy. I show you in the opening of our lesson today. We have 2 points, and we not have a slope. So the first one, you must write the slope. M equals the subtractions of y coordinates over the subtractions of x coordinates. So it is 0 and minus 5 over 7 minus 3. It is negative 5 over 4. And you choose 1 point to write the slope intercept 4. Point slope 4, point slope intercept 4. I choose the second point because it have a coordinate, y coordinate is equal to 0, and it's easier for you when you compute the expressions that have a value of 0. So we can write the equation of line. Y minus 0 equals negative 5 over 4 times x minus 7. So y equals, maybe you can expand these expressions, or maybe you can rewrite it. Expand. Easy. Step 2 is step 1, and we move to step 2. We substitute the coordinate of the last point to the linear equations here. So we have A11 equals negative 5 over 4 times x negative 1 plus 35 over 4. We can choose. It's 11 equals negative 5 over 4 times negative 1 is 5 over 4 plus 5 plus 35. It is 11 equal 10. It's not correct. Maybe I have some mistake. So I will solve it here. I will check the questions. 3, 5, 7, 0. Negative 1, 11. Okay. Yeah, I'm right. I now have a mistake. So, when we see here, 11 equals 10 is not correct. So, we can have a parenthesis to imply here. Is not correct. And our last answer is 3 points are not collinear. Conclude. Three points are not collinear. Okay, so when we conclude 3 point are collinear, so I want to choose another point to make it easier for you. So if the point here is negative 1, 10, so when you do the step 2, you have the answer. You have 10 equals 10. If I change the questions, not the point negative 1, 11 to it is negative 1, 10. So we have the last sentence here, that equation 10 over 10, so it's correct. So we can conclude that 3.35, 70 and negative 111 are collinear. Okay. So in the questions, 3.2570 and negative 111 are not collinear because that 11 is not equal to 0. So the coordinate of the third point, the last point, not satisfied the linear equation here. So it's not lies on the same line with the first and the second point. Yeah, it is the first method to do these exercises. And we have option 2. In the option 2, you have the same step 1, the linear equations of the line going through 2 points. And in the steps 2, you not substitute the coordinate of the last point to the linear equations to examine the certifications of the coordinate to the linear equations. You must write step 1 here. See me. Step 1 is the same as step 1 in option 1. And step 2, you write the linear equation through 2 other points. We have a step 2 now. And I choose the second and the third point. We have M equal 2 M equal 11 minus 7 minus 0 over negative 1 minus 7. So the answer is 11 over negative 8. So we have 2 different slopes. So we can conclude here 3 points are not collinear, because if 3 points are collinear, they must have the same linear equations when the linear equations go to 2 points here or 2 points here. So in the slope we have that the slopes are not equal. The slope are not of 2 lines are not equal, so we can conclude 3 points are not collinear. Yeah, it's either 2 options to do this exercise. I want to say again, when you check 3 points are collinear or not, you must write the linear equations through 2 points, and then you substitute the last point to the linear equations. If it's satisfied, it is they are collinear, and it's not satisfied in our questions here. They are not collinear. Or maybe you can write another linear equations through through two other points, and you can compare the slope of the linear equations of two lines. If they are not the same, they are so you can conclude that 3 points are not collinear. They don't lie on the same line. This is the way to show work to determine if 3 points are collinear or not. Easier? Easy. Okay. I clear my board, and we can do some more exercises together. Practice my perfect. So do the more exercise you do, the more clever you are. I use alcohol to clean my board clearer. It's a rainy day. I not have a good tools to clear my board. I have some mistake when solve the exercise, but maybe some mistake make our lessons more interesting. Nothing is perfect. Rough without using the calculator, 3 linear equations. The first one, y equals 3x plus 2. You sketch the rectangular coordinate system here. The first method, you choose 2 points. When x equals 0, y, you substitute the x value to the equations, you have y equals 2. And x equals -1, y equals -3 plus 2 is -1. So you have 2 points, 0, 2, and -1, -1. when you sketch a line, you just have you only want to have 2 points, so you sketch the line to 2 points. The first point 0, 2 here, and the second point negative 1, negative 1. Maybe I sketch the axis here. So I sketch. Oh my god, yes, not straight. So I use the ruler. It's already and I have a lot of mistake. Terrible. Okay. Yeah. Let's do the line y equal 3x plus 3. Negative 1, negative 1. The second way, the option 2, you don't want to choose 2 points. You know that 2 is the y-intercept in the slope intercept floor, so it is 2. And it have a slope 3, so rise over run are 3. So rise is 2, is 3, 1, 2, 3, and run is 1. Here, and you sketch. Of course, the slope have a positive value, so the outline is upward to the right. This is the first question. Question B. It's equal negative 2. I think now the question is very easy. This is negative 2, and you sketch the line perpendicular to the x. It is equals negative 2. And question C, 2x plus 5y plus 10 equals 0. So when you see the general form, the easiest way is choose 2 points. You choose x equals 0 and y equals 0 because it's easier for you to solve the equation with the value is 0. When x equals 0, you substitute the x value to the linear equation. You have 2 times 0 plus 5y plus 10 equals 0. So 5y equals negative 10. So y equals negative 2. So the first point is 0, negative 2. When y equals 0, you substitute the 0 to the y variable. So it is 2s plus 5 times 0 plus 10 equals 0. So you change 10 to the right side. It is 2x equals negative 10. So x equals negative 5. We have a point negative 5. So you can see that when you choose x and y equals 0, it is very easier for you to solve the equation. And also we have it is the x-intercept, and it is y intercept. Oh my, sorry. It is y-intercept and it is intercept. S-intercept. So the first point, 0, -2 here. And the second point, oh sorry, 0, -2 here. Maybe I have not a breakfast, so I don't have energy to solve exercises. This is -2, 0, -2 here, the first part. And the second point, -5, 0, -2, -3, and 4 will be -5 here. And we sketch the line. Yeah. I think it's easy. Okay. In the question says, you see that we show the y-intercept and x-intercept. So the last form of our exercise is about finding the intercept of two graphs, and I want to solve you two more questions before we have the end of our class today. Question. Find the point of intersection of the graphs. 2x plus y equals 7 and 2x minus 3y equals -1. Okay? So when you want to find the intersections of two graphs here, it is the point satisfies the system of equations of two equations. So we have a point of intersection is the point satisfied the system of equations of two equations. Equals 7 and 2x minus 3y equals 7. Have you note the way to solve this equation system? The first one, it is 2x, it is x. So you must multiply the first equation by the factor opposite side of this coefficient. So it is negative 2x minus 2y. 7 times negative 2 is negative 14. And you do the operation addition side by side. So we have, I'll rewrite it here now. Negative 2x plus 2x is 0. Negative 2y plus negative 3y is negative 5y equal negative 14 plus negative 1 is negative 15. So y equals negative 3. Positive 3. When you have y coordinate, you substitute y equals 3 for y in the equations of the first or the second linear equation. So you have, maybe I substitute 3 for y in the first equations because it is see that it is so easier now for the second one. So the last we have x plus y is 3 equals 7 and x equals 4. So the last answer, point reflection, is the point for 3. Point of intersection. Maybe you can do the way to solve the equation system by multiply both sides of the first equation by the positive by the positive 3 is in the opposite side of the coefficients before y. So we in the option 2 we can solve is in option 1, and we have option 2 multiplied the first equations by 3, so we have 3x plus 3y equals 21, and we have the same second equation. Two x plus 2x is 5x. 3y minus 3y is 0 equals 21 plus negative 1 is 20, and s is 4. And we substitute x to the first equations, so we also have 4 plus y equals 7, and also y equals 3. So it's having the same expression. It's 4 and y equals 3. It's 4. Yes. It is the way to find the point of intersection of the two graphs. The last question for our lesson today is also find the intersections of the graph, but we change the graph. It is x squared plus y equals 4 and 2x minus y equals 1. It is a quadratic equation, and it's still a linear equation. I clean the board. When the questions require you to find the points of intersection of two graphs, the first one is parabola, or we can say in another way is in the quadratic equations, and the second one is a graph line, or it is a linear equation. The first step, you must isolate y variable. Step 1. We isolate y in the first equations or in the second equation. We have two options. So I is in the option 1 for you. Option 1 always the easiest option. But when you do exercises, you are so confused and you don't remember what to do the option 1 or option 2. So I show you two options, and I think that when we repair well at home, you will get a high score when you have actually exam in your high school. 2x minus y equal 1. So negative y equals 1 minus 2x, or y equals 2x minus 1. Then we substitute y here for y in the first equation. It is that. We have the first equation in the question equal 4, and y equals 2x minus 1. So we have x squared plus 2x negative 1. I exchange 4 to the left side. Negative 4 equals 0. And also clear my want to have more space to continually solve this equation. So it is x squared plus 2x. 5 equals 0. Okay. This is a quadratic equation. And have you know the formula of delta and to solve this equation? Yeah, I will review you some formula to solve this equation. We have a delta equal e squared minus 4ac. So it is 4 20 24. And we have 2x, s1 and s2. It is minus b plus square root of 24 over 2a, and negative b minus square root of delta over 2a. In the formula of quadratic equation, I think that you already learned in the secondary school. So I can simplify it. So we need the negative 1 plus square root of 6, and it's 1, negative 1, negative square root of 6. So we substitute x for the first step here. So we have y equals 2x minus 1, it is 2 minus 1. And the last answer is negative 3 plus 2 square root of 6. And we have y2 is 2x minus 1. It is negative 3 minus 2 square root of 6. Yeah. I review some formula of quadratic equation. And so we have a 2-point intersection. The first one is -1 plus square root of 6, -3 plus 2. And the second one is -1 negative square root of 6 and -3 -2. This is the last answer. Option 2, it is also the same way as option 1, but you isolate y variable in the first equation. Option 2. Step 1. X squared plus y equals 4. So y equals 4 minus x squared. And step 2, you also substitute y here for the second equation. So you have 2x minus y. You must have opened the parentheses here. Lots of students don't remember to have a parenthesis here, so it will give you a wrong answer. -4 minus x squared equals 1, and you distributive multiplication here, expanding the equations, we have 2x minus 4 minus negative x squared is plus x squared. We change 1 to the left side, so it is -1 equals 0. And you rearrange the term in the largest power of x to the smallest power of x. So we have x squared plus 2x. -4 minus 1 is -5 equals 0. So we see that when you do the option 1 or you do the option 2, they have the same quadratic equations here and here. So we have the same last answer for this question. Okay, it is our lesson today. In the last questions, we review the formula of quadratic equations, the solutions of quadratic equations by using the delta and the formula of solutions. And we see that in the first equations, it is a parabola, and in the second equations, it is a linear equation. So when the the intersections of parabola and linear equations must be have 2 points, 1 point, or no points. So it is the same meaning as the solutions of the quadratic equations. In these quadratic equations, we also have 2 options. second, two solutions, one solution or zero solution or no solution. So I think that you must remember the formula of quadratic equations is very important to you. And maybe if I have a time, I will review you in my later chapter or later lesson. Okay, goodbye everyone and see you later. Thank you for watching.